This is a part 1 of the Azure Machine Learning Studio. In this tutorial, what we would be doing, we would be creating a new pipeline, and then we would be importing data. Here, say we would be importing the automobile data. And later on, we would be preparing that data set and then training our machine learning model. Here, we would be using the linear regression model to train our machine learning model. Then we would be evaluating the machine learning model. So here, what we would do, we would be creating a new pipeline. For that, we would be creating a new workspace. Like when we open the experiment, then the new workspace opens. But as I have already created some workspaces, so those gets visible here. And if one wants to create a new workspace, then on clicking that experiment, one can create a new workspace, and one can rename that workspace here. So here, these are my new experiments. On clicking it, now it's a time to create the blank experiment. And in this blank experiment, what we would do, we would be dragging the data, and then we would be cleaning that data, and afterwards we would be splitting the data into the training and testing model. Then we would be scoring that model, evaluating that model. So let's see how it could be done. So here, what I would do, I would just search the automobile price data, and this data, then I will drag it here. And next, the thing, if this data is to be seen, then on right click, I would get some options where one can visualize the data set. So here, on right clicking this data, I would get these options, and on clicking the visualizer, I would get the visual form of the data set. And now, it's a time to clean the data. As we have seen in the previous slide, that in case of a normalized loss, there are many columns, many rows. In many rows, the values are missing. So what we would do, we will select one data set, and there we would be excluding this normalized loss. So in order to do this, I would be just searching the select column in the data set. And here, what would happen? Selecting the data set and then dragging it here in our pipeline canvas. So what would happen right now, that on clicking this select column in the data set, I have to launch it, and this will prepare my data. Here, on clicking the select column in data set, I would be launching the column. Now I would remove the missing data. On clicking it, I have to select with rules column. So here, I would be selecting all column, and here I would be excluding only normalized loss. In this way, it would exclude the column with the name of a normalized loss. So this thing would be done. Afterward, it's a time to clean the missing data. So, although we have tried our best to clear the missing data column, but we have to make sure that our data is in a raw form, which is pretty much cleaned. So I would be dragging the clean missing data. So for that, I would be again searching in the search box, and I would be getting the clean missing data under the manipulation, and I would be dragging it here to my pipeline canvas. Now, on clicking the clean missing data, for that, first of all, I have to create a one link from the select column in the data set. In this, if you see in the pipeline canvas, the whole frame is linked with each other. Now, on clicking it, I would be choosing the cleaning mode as a remove entire row. Afterwards, On clicking the remove, one can click on the run, and this way the data will be clicked. But again, there are many columns, and these columns are not required in order to train our model. So what we can do, we can keep the limited columns for our data, and we can omit others. So for that, I would choose again the select the column data set, and there what I would do, I would click on the launch column, and there I would choose only the columns with the make, wheelbase, engine size, horsepower, peak RPM, price, body style, and I would be leaving the other columns. In this way, I am making my data set to kind of accommodate kind of a data set where it would become more lucid for us or for the training model to figure out the correct result. So let's see how the training. So as you can see on clicking, as I have explained earlier, on that now I have reduced the columns, and I have kept only the relevant columns. Now it's time to split the data, and here the splitting of a data is required to divide the data into the train and the test model. So what would happen, and again this thing I have taken by searching the split, and here under the sample and split this thing would come, and I just dragged on the pipeline canvas. And on clicking the split data, I would be making sure like how many fractions I want to keep it for the testing and the training purpose. So here I am taking only 75% or 0.75%, 75 portion of the rows for the training purpose, and the rest would reserve for the testing purpose. So next, now we have done the splitting of our data. Now let's train the model. So for train the model, again there is I would search for train in the search box, and under the machine learning, under the train I would be choosing the train model. I would be dragging here, and one has to make sure that I would be making a link between the train model and the split data. And next, now here which training model I would be using. So here the thing is that I would be there are many regression techniques, Bayesian regression technique or many other, but I would be choosing the linear regression technique, because as I am dealing with the numeric data, so I would be choosing the linear regression. So here again I would be making a link between the train model, which specifies that I would be using a linear regression, and which data I would be using. This would be a split data or the refined data which I have taken, and which I have kept for the training purpose. And afterwards, with respect to the train thing, I would be making sure with respect to what I want to train my model. So with respect to the price, I would be training my model. So on clicking the train model, I would be launching that column, and then I would be putting in the price as a training parameter. Now we would be scoring the model, because now the training has been completed. Now we have to make sure that whether the model which we have created is up to the mark or not. And here say, with respect to the training, we are pretty sure that we fed the training data, and with respect to the split data, we know that we have a test data as well. So here the things would be matched, whether our model gives a true result or not. And on clicking this score model, we would be running our system, and on running the all cells, we would be getting the result. And on right clicking the score model, then we would get the appropriate price for each car. Here say, with respect to the Subaru or Mitsubishi, the appropriate score label or the appropriate price would be depicted. As in the dataset, one must have noticed for the Subaru sedan, there are many columns, many rows which existed, but right now it is giving us the appropriate or the most accurate price which is related to that brand. So now let's add the evaluate model, and evaluation would happen which would make sure that whether our model is performing at par or not by comparing the results with the testing. So here what would happen, that on evaluating the model, I would be again searching the evaluate model from here, and I would be dragging it here and making a link between the score model and the evaluate model, and then running the thing. And afterwards I would be getting the evaluation results, and I would be visualizing the results. So here the mean absolute error which is coming like 1656. So again I would try to consolidate the things which I have done right now or just now. So like the linear, there are some questions which I need to answer, like why I have choose the linear regression, because we want to predict the price which is a number, so we have used a regression algorithm. So for this, the linear regression model is the most appropriate, or it's appropriate to deal with. And with respect to the evaluation model, so what happened, using the evaluation model, we entered the evaluate in the search box, and then we found evaluate model, and then we dragged the final pipeline which I have earlier shown. It looks like this. So here what is happening, that whatever training and testing of our data happen, it would get evaluated, and it would show us the result, that how far our test has been performed, and the lesser the error which we see here, like after clicking the evaluate model, the more accurate our result. For each of the error statistics, smaller is better. A smaller value indicates that the predictions are closer to the actual value. For the coefficient of determination, the closer the value is to the 1, and the better is the prediction. So coefficient of a determination, if it's closer to 1, the better. So here we are getting 0.9, so our evaluation is better. So again, this is the step, these are the steps which we have followed. Took the data, cleaned the data, removed the normalized loss, cleaned again the missing data. Again we just took the only specified relevant columns, and then we split into the train and test, and then we chose a model, linear regression model chosen. Then we score the model. For scoring the model, it means that we just came to know that whether our trained and testing model, those are performing better or not, or what would be the appropriate price for the respective model, car model. So only that would be shown. So here in the training model, well, it would make sure that that from the numerous car prices of the one brand, what would be the most appropriate or the average price of that specific car model. So that's it for our part 1, and I hope so that you have enjoyed, and we can submit the pipeline afterwards, and we can deploy it as we need so. So thank you.